If you're looking for a content explaining what is Falco and how to report security events back to your observability solution, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is going to be part of the security playlist where we covered lots of episodes. We recently explained the security best practices related to Kubernetes, and we introduced OPA Gatekeeper, and in fact, it reminds me that I need to produce an episode on Kubernetes. But never mind. So, today's episode is going to be focused on a runtime part, so detecting suspicious security behavior within an environment. So for that, we will focus, and I think, on the most popular agents of the cloud-native space, and I'm referring to Falco, of course. So if you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you are going to learn from this episode. We'll start with a short introduction reminding all the potential suspicious events that we need to detect to secure our Kubernetes runtime. We'll of course present Falco, no surprise. We will present the syntax to build Falco rules. We will look at FalcoSidekick, which is another project from the Falco team. And last, we'll understand how we can extend the observability using Falco. In the episode explaining how to secure your Kubernetes cluster, we highlighted that security is going to be part of your entire lifecycle of your project. So when building our applications and containers, when deploying our applications, and of course, when our application is currently running in our cluster. Once our application is running in our cluster, it could clearly happen that we can forget something, especially in the privileges that we are giving to our pods, to our containers. If we have a container having significant rights, then we are clearly helping the hacker in controlling our containers and of course in our nodes. So what are they trying to achieve once connected to our container? Probably our container is giving a limited rights. So the first thing the hacker will try is to collect the current context related to the security in this container. So it will try to understand with the type of machine, the process running in this container, the environment variables currently available in this container, see the current privileges, identify the kernel capabilities of this given container, and if the machine has the rights to install mandatory tools to scan the ports or to do any major damage on the actual container. Of course, he will try to search for any sensitive files, so password, tokens, whatever it is. That's on the container level, but he will probably want to interact as well with the Kubernetes API. So if the pod has an access to the API, he can simply use curl or simply kubectl to understand the current privileges that this container has on the Kubernetes API. Then the idea to sniff the traffic to identify another workload having higher rights. From this list of actions, it means that they are standards interactions that a hacker will have on our containers, and that will be translated into common syscalls in the kernel of the node. So why the node? Well, remember, the container pods are simple processes running on the node. So if we rely on an amazing technology that I have already presented on this channel, and I'm referring to eBPF, we can easily deploy eBPF probes that will watch for specific syscalls on our node. And if you want to understand what is eBPF, then I would recommend to watch the dedicated episode. So with the help of eBPF, we can easily detect a process trying to access to specific folders or change privileges or try to run a new process in the container and more. That is why most of the security runtime agents usually rely on eBPF to be able to detect suspicious activities. Those agents are usually configurable, but they always come with predefined rules. Oh God. So even if we're putting a lot of efforts to apply the right security methodology, the security rules, limit the privileges, there would always be some vulnerable workload in our cluster. That is the reason why we need those eBPF agents to automatically detect any suspicious activities in our cluster. It's a bit like a camera that we are placing on each level of our building to detect any suspicious movement. So no surprise, there are several well-known agents that could be used, such as Falco, Tetragon, Kubernetes, and probably more. So if you're aware of any other agents, please drop a comment below. Falco is by far the most popular runtime security agents in the cloud-native world. So when referring to Falco, we usually think about detecting suspicious kernel events. Well, it's kind of true, but Falco at the end is a rule-based agent that is triggered against events. So Falco can receive various sorts of events, but in the most common use case, it would be a kernel event. The event will go through a set of Falco rules to determine if the event is matching one of those rules, detecting suspicious activities. If the event match our rule, Falco will produce a log in the Falco agents with various details such as the rule name, the detail of the event, and probably more fields. In fact, the output is structured through the rule defined in Falco. When deploying Falco, we will by default have the eBPF probes to capture kernel events, but we will also can install plugins that will add extra events in Falco. Currently, there are a limited number of plugins, so the Kubernetes audit to collect the Kubernetes audit files, Okta, and CloudTrail. And also have a native integrations with gvisor. That is an interesting project from Google to limit the interactions of our containers with the user space of the environments. So both projects, so gvisor and Falco, is an amazing combinations. So blocking with gvisor and detecting with Falco. Of course, Falco provides an SDK allowing us to write our own plugin. So let's say I could write a plugin that will notify Falco every time there is an Is It Observable episode released. And then we could create a rule, like if it's related to security, then we want to be notified and something in log. So this will produce a log or details of the security episodes in the Falco output. Keep in mind that Falco is a rule engine. And yes, I agree, when deploying it, you will have by default the Falco library that will deploy eBPF probes to capture kernel events. So it will mean that Falco will run as a daemon set in our cluster to detect the kernel events of each node of our cluster. What is great with Falco that it will be deployed with predefined rules designed to detect any suspicious usage of the Kubernetes API, any process spawned in our container, access to any sensitive folders of our containers like /etc or /userbin and so on, create symlinks and more rules. So here are the lists of the predefined rules that you will get if you deploy Falco. The default Falco rules will be stored in the container in a specific folder, so /etc/falco/falco rules.yaml file. Of course, we have the freedom to create our own rules, but even if the syntax is simple, creating a rule in Falco will clearly mean that you need to know the exact security event that you're looking to capture. So by defining the type of process, the kernel activity, and so on. So it clearly means that if you have decided to create your own rule, then you already have a significant expertise in the tool and in security. A Falco rule requires several settings and a specific structure. So here is an example of Falco rule. You can see that there's a rule name, there is a condition, there's a description for the rule, the actual rule, there is an output, there is also a priority, and you can also add tags. So the most important part here are clearly the condition, which is a set of Boolean conditions, and then the output that will generate the output that we will be sent in the Falco logs. So when building our conditions, Falco provides several objects. So we have event for the actual event. So you can have event.type in, for example, open and open at. It will filter kernel events related to open files in our systems. We can also have event.type equal exec CVE for process launched. Events has several property out of just the type. So you can have dir, meaning the directions. It could be either at the entry of the event or it could be at the exit of the event. Of course, it has many properties. So here is the link to all the property of the event objects. Falco provides other objects. So we have proc for the details of any process, thread, a user, group, containers, FS for file systems, FD for files, Kubernetes for Kubernetes metadata. So with all those objects, we can create precise rules on how to capture the exact event. On the condition side, Falco provides lots of various operators. So we have, of course, equal, non-equal, less, greater, whatever, contains, start with, in, exists, and more. So we have all the required operator to create complex rules. Falco also provides a couple of functions to help us dealing with the format of the events or the variables or the values. So we have to lower, to upper, and we have base64 to decode base64 values. On the output, we can also, of course, reuse all those objects or variables to structure our output. Of course, they will be suffixed with percentage to display the actual value of that variable. When building a Falco rule, there is a big chance that a set of conditions would be reused in many other rules. So that is the reason Falco has introduced the notion of a macro and lists. Lists will be used to create a set of value that could be used in several rules. For example, here it is. We can see that my program has several items, so ls, cat, and whatever. And then you can see that I can refer that lists in my rule with the conditions, for example, using in the operator in. And for the conditions, it will rely on macro. So macro will be a list of conditions with different operators. So you can have either one condition or several conditions. So here, for example, we have the macro called access file conditions. And here we can see that the event type is open and we can refer that in one rule or several rules of our choice. Last, a rule could be easily enabled or disabled in the rule definition. For example, here you can see that there's a property enabled equal to false. To replace or modify an existing rule, we will add the override property that will define if we are appending the existing rule or replacing it. So here is an example. For example, here we are appending an existing list. As you can understand, Falco will detect any suspicious events from the rule defined and will by default produce logs in text or JSON format. So to take actions, we need to collect the logs from Falco, parse them, and then build the right workflow to react on the Falco event. But to simplify this journey, Falco provides another project called FalcoSidekick that will simplify this process. When FalcoSidekick is deployed through Helm, the Falco agent will be configured to send the events directly to FalcoSidekick. And it will also produce event and std out in a JSON format on the Falco agents. Meaning that if you're having FalcoSidekick and you have already a log agents running, you may have the Falco events ingested twice in your environment, so you will need to filter the Falco pods from your log collection. FalcoSidekick provides various outputs. So the purpose of FalcoSidekick is to parse the events and then push them to a destination. So where can we send those events? Well, there are plenty of options. So it could be any observability solutions of the market, such as Dynatrace, Datadog, and more. It could be a chat application such as Slack or Teams. It could be a log platform like Elasticsearch or QuickWit or more. It could be a messaging systems. It could be a storage like S3. It could be sent by email. It could be a trace using OpenTelemetry. That sounds very exciting, so we'll talk about it later on. It could be a web UI, and here it will be the FalcoSidekick UI. And finally, you have a response engine with the latest products of the Falco community called Talon that could trigger workflow based on Falco events. And if you want to have the entire list of outputs, check the following URL. FalcoSidekick could be deployed with the FalcoSidekick UI, and the UI at the end is just a tool visualizing the Falco events. But if you're already sending your events to a destination like an observability solution, then I guess FalcoSidekick UI has a limited value. Each output requires specific settings, so check the documentations of the output of your choice. One small note is by default, all the configurations of our outputs will be stored in the community secrets in FalcoSidekick. On the observability side, it clearly provides the data that we need. So first, the actual health of Falco. This can be easily observed by enabling the metric server of Falco. So by running the following installation, so here a Helm install, you can see that we have a set metric enabled true, and this will include the metric server of Falco. The metric server will expose lots of metrics on the rule engine of Falco and the eBPF probes running to collect the current events. All the metrics on the Falco agents would have a prefix called Falco security, so you can search for them to find the metrics. There are plenty of metrics, so we can classify them by different categories. So we have the resource usage, so we have like metrics like Falco memory PSS bytes or ERSS bytes. We have the Falco CPU usage ratio and more. So a couple of metrics related to the rule engines with Falco rules counters to count the actual rules, metrics on the events reported, so Falco N event total and Falco events count, and has specific metrics on the Falco behavior of the buffer used by Falco. But when it comes to extending the observability with Falco events, we can easily rely on the log produced by the Falco agents. And the amazing thing is that Falco attach to the events the MITRE or techniques, I don't know how to name it, but MITRE is an organization that formalizes the attacks per category. So by doing analytics based on the MITRE technique, we could easily classify our events per security priority. So FalcoSidekick is an interesting project, but I don't think it's really mandatory because the raw data is already in the log produced by Falco. Of course, you would have to do more processing on the log agents to extract the relevant data out of the Falco events. So it's really up to you. The easy solution, of course, would be to use FalcoSidekick to remove this complexity of processing. FalcoSidekick provides an unauthorized output. It is technically converting the Falco events into an open telemetry trace. So far, I'm not convinced of the value using traces instead of logs to do the event analytics. So for such a use case, especially security, I probably don't want to sample any of the Falco events. So it would be much better to have like a open telemetry logs or open telemetry events that push the process events to a collector or to an open telemetry endpoint. But again, this is my opinion. So let me know by dropping a comment what you think about this open telemetry trace on Falco events. When dealing with Falco, I will either use FalcoSidekick or collect the logs in with using a log agents to report suspicious activities in my environment. But side of that, I will clearly scrape the metrics provided by Falco to also report the health of our Falco agents by looking at the CPU usage, the memory usage, the threads, the buffer, the number of events detected, the number of rules managed, and so on and so forth. In this particular use case, I will exclude the traces and mainly focus on logs and metrics to report the security and the health of my agents. That's it for today's episode related to Falco. So no surprise, Falco is very popular, so I guess you already heard about it and you know how to use it. I think what is really powerful is the rule engine of Falco. Again, I have not built my own Falco rules. I may just append or change existing rules to detect more precise events, but I don't want to create my own rules because by far I don't think I have the expertise for so far. Maybe one day I would have it. I also like the fact that the logs produced by Falco has lots of details. So either you can have the Falco logs produced in text, that is an option in the Helm charts, or in JSON. So when using JSON, it's much more easy to parse, obviously, because we can extract easily the properties. And of course, one thing that you should consider is that each rule will produce different outputs with different fields. So The extractions or the processing of the fields is really depending on the rule. So that's why whereas FalcoSidekick brings value, because this complexity of detecting and parsing properly each rule individually will be managed by FalcoSidekick. So this processing task would be removed completely from our shoulder, and we can focus just on the analytics side. On the metric side, I think it's quite powerful to get enough details through the metrics exposed by the Falco agents itself. You also have FalcoSidekick producing metrics as well. They are also interesting, but I think that just the Falco agents metrics is by far enough to understand the actual health and the events, everything that could be suspicious in our environment. I have prepared, as usual, a tutorial. So here is the link to the GitHub repo. So check it out. I have an environment. I try to generate some suspicious events out of that. So just to play around, and that's usually the tutorial helps me to build the actual episode presented today. So if you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode.